Hello, Emilio. Hello, my niece Patricia, and hello, everyone. Today we are going to discuss some basic concepts about nuclear physics. So, the nucleus is a particle which is made usually by two types of particles. That is a proton, okay, a proton, and also something that is a neutron. And together form a nucleus. Nucleus, okay? So the notation to express a nucleus is given by one symbol of the atomic periodic table, and we must to write down the number of protons here, and here the number of neutrons, and in the upper side we have to write the total number of the atomic, usually is the atomic number, which is just this addition of the number of protons and neutrons that people wrote like A. Okay, but instead of write P and N, it's more convenient use the notation that is given by, for a proton, we wrote the letters Z, and for neutrons we wrote N. So this is the notation that we will use in nuclear physics to represent a nucleus. Okay, so when we have just, for example, when we have only one proton, okay, this nucleus is the hydrogen. We have here just one proton, okay, and we have a 0 neutron and one proton. This is the hydrogen nucleus. When we have one proton and we have one neutron, we got another nucleus, which is an isotope that is usually, we can write like we have here one proton and one neutron, so we have here 2, and we have one proton and we have one neutron, and this nucleus, the name of this nucleus is deuterium. Is when you have only one proton and one neutron. Let me write here. the name of this. This is the deuterium. And when we have one proton and we have two neutrons, and everything together makes a nucleus. This nucleus here, now we will have one proton, two neutrons, and the total number here is 3, and the name of this is a tritium. This nucleus is a tritium. So we have we have the same symbol to express different nucleus, and each nucleus has the same number of protons but different number of neutrons, and in this case those extra nucleus are isotopes of the hydrogen. So here we have the isotopes of the hydrogen. Isotopes is when you have different nucleus with the same proton but different neutrons. Okay, so in nature we have 3 types of rays that we have seen experimentally. I mean, when you have a nucleus, okay, there are 3 types of radiation that people have seen, or there are 3 types of radiation which people could see in the laboratory, and also in or okay, not only in laboratory, but people discovered this is at part of them at laboratory, or usually we study at laboratory, but let me write down this. Okay, so we have 3 types of radiation. The first types of radiation is the alpha radiation. Another type of radiation that we have from the nucleus is the beta radiation. And the third one that also we have is the gamma radiation. Now just I want to tell you only these types of radiation that I am interested to explain. That is the beta radiation. When you have, that is given by the process of beta decay. Okay, so when you have there are 3 types of beta decays. I will explain the basic, that is given by the beta minus decay. there are three types usually. Of course, there are more complex processes, but now just I will focus on the beta decay, the beta minus. Also, there are B plus and some process that calls electron capture, and more complex process that is involved in beta decay that is given by zero neutrino double beta decay and to neutrino double beta decay, and another types more complex. But now just I will focus on at the moment on beta decay. So beta minus decay. When you have, for example, let's check this. Let's check the isotope of tritium. Okay, so when you have one proton, for example here, let's check this case. When we have one proton and you have here two neutrons, the nature, the preferred, this is the hydrogen is the okay, this is more stable, the proton, but this is the deuterium also. Okay, when you have here, we can see that the tritium has more neutrons than protons. Therefore, the nature prefers something like be more symmetric. I mean, here we have like, if we have one proton, we should think that the nature prefer only have one neutron and not two neutrons. Therefore, the nature somehow must have one proton and one neutron. Okay, but if you see here, we are yes, the nature prefer change the neutron, but will change not in this way, will change into a proton. Here we have something like this. The neutron, one neutron will change to one proton, okay? But the mass of a neutron always is greater than the mass of a proton. Let me check if I am okay. The mass of a neutron is more massive. Okay, therefore we require, in order to have the conservation of energy, here we require to add something, that is add the electron. Okay, here is an electron plus something new, that is a neutrino of electron, antineutrino of electron. So this is an electron, and this is antineutrino. So this process is called beta minus decay. When one nucleus, inside one nucleus, one neutron transform to one proton and emit one electron plus one neutrino of electron. And this process occurs in the nature and is a beta decay. Minus beta decay because we have here the minus of the electron. So this is